Hey guys, so in the last lecture we have seen heat balance sheet that we have found out how heat is being used, that is how heat is being expenditure in various different factors due to different factors, and how much heat is being supplied. So at the end the total of both heat supplied and heat used should come as equal to 100%, means equal to same. And also we have seen various flow meters, that is viscous flow meters, then air consumption. For measuring the air consumption we have seen few meters. So now we have also seen few gravimetric flow meters, then also the volumetric flow meters to measure the fuel measurement. So now we will see today various factors affecting engine performance. So what are the various factors affecting engine performance? Affecting engine performance. So what are these factors? So today we are going to study this. So let's start one by one. So important variables which affect the engine performance are: first, compression ratio, that is CR. So the increase in compression ratio increases the thermal efficiency. So increase in compression ratio will increase thermal efficiency, will increase the thermal efficiency of the engine. However, increased in compression ratio increases the pressure and temperature, which results in higher friction losses. So this will also increase the pressure and temperature, which may result in higher friction losses. So which will increase the friction loss, but efficiency will increase. So the increase of the loss is slightly lower than the increase in the output power. So moreover, the increased compression ratio tends to increase detonation. It will increase the detonation in SI engine. Thus compression ratio is limited to certain value for better performance. So you cannot increase the compression ratio beyond some level. Then the second factor that affect the engine is air fuel ratio. The most is air fuel ratio. So lean mixtures are used for economic running of the engine, while the stoichiometric air fuel ratios are used for development of maximum power and during acceleration of the engine. So this also affect the performance of the engine. Then third is rate of combustion. So rate of combustion. So rate of combustion and ignition timing. And ignition timing. Ignition timing. So in case of SI engine, that is spark ignition engine, the ignition timing are adjusted to provide the combustion rates such that the maximum pressure occurs to the beginning of power stroke, that is at top dead center for smooth running of the engine. In case of CI engine, the fuel injection is so timed that it provides the half of the total pressure rise during combustion, almost near to the top dead center for optimum performance. So this rate of combustion and ignition timing also has very much importance in engine performance. Then engine speed. So increase in speed of engine increases the mass flow rate of air. So as speed will increase, so it will increase the mass flow rate of air. So more air will be required. So it increases the power output. So this will increase the power output. So our increased speeds also increase the friction losses. Thus, the optimum of the engine should be adjusted so as to provide the optimum performance. This will also increase the power loss very much. So this will result in decrease in efficiency. So an optimum speed should be used. So you might have seen that generally in bike an economy range is given in the bike meter. So if you drive your bike in that much range, then your fuel will be saved uh, in very much good amount. So your fuel will be saved and it will help you in saving some money. So that is the economy range. You must have seen that. So that is the engine speed. Then fifth factor is mass of intake charge. Mass of intake charge and supercharging of engines and supercharging of engines. Supercharging of engine. So higher the mass flow rate will provide the better volumetric efficiency. So higher the mass flow rate will provide the better volumetric efficiency and power output, and thus power output will be also higher. So mass flow rates can be improved by supercharging the engine. So this can be improved by supercharging the engine. But in case of SI engine, the supercharging is not employed due to increase in tendency of detonation, whereas of supercharged CI engine runs smooth. So this will not work in spark ignition engine, but it can work in compression ignition engines. So these were the factors, five factors due to which the engine is being affected. So we can increase the performance with these five factors by knowing these five factors, and we can decrease the performance by not understanding these five factors. So that is very much important. So methods of improving engine performance. So we have seen what are the factors. Now we'll see what should our methods should be to increase the engine performance. So I will just list down the methods to improve engine performance. So what are the methods to improve engine performance? So basically engine performance can be improved by increasing the energy input to the engine or by improving the conversion efficiency of the engine. So there are various factors. So first is by increasing the mass flow rate of the mixture. So increasing the mass flow rate of the mixture, that is air plus fuel, so total mass flow rate. Then the second is supercharging of the engine. Supercharging of the engine. Then the third is use of larger piston diameters. Use of larger piston diameters. Then fourth is use of fuels of higher calorific value. HCV fuels, higher calorific value fuels. Fifth, increased engine speeds. Increased engine speeds. Then sixth is by improving volumetric efficiency. By increasing the volumetric efficiency by reducing pressure loss intake and manifolds and reducing the mixture flow restrictions. Then seventh is use of higher compression ratios. Higher compression ratios. Then eighth is use of fuel additives. Use of fuel additives. Exhaust gas recirculation, positive crankcase ventilation, etc. And ninth, reduction in heat losses. Reduction in heat losses. So these are the various methods how we can improve the energy energy performance of an engine. So now we'll see the characteristics performance of an engine due to various different conditions. So performance, we'll see performance, characteristics of engine, performance characteristics. Performance characteristics of an engine. Performance characteristics of an engine. So engine performance characteristics are the graphical representation of engine performance. So laboratory tests are performed to determine indicated power, brake power, and mechanical efficiency and thermal efficiency and also specific fuel consumption SFC, and this performance characteristics of SI and C engine we will see today. So let's start with SI engine. So first is SI engine. So I will just draw few diagrams of power P to the speed V to the speed. So So here you can see that there are three lines drawn on the graph of power versus speed. So on the x-axis there is speed and on the y-axis there is power in kilowatt. So here this line is indicated power. This is brake power. So as you can see, the indicated power will be always greater than the brake power, and it will be the same. It will follow the same curve as indicated power, and this is the frictional power, that is the difference between these two, indicated and brake power. So as you can see that as the difference gets increased, so the frictional power will increase. Now you can also see here that as speed increases, the power is increased, but after some limit the power is reducing in indicated and brake power. So this is the effect of speed on the power. So so why this speed, after certain speed the power is not increasing? So the mechanical losses increases with the increase in speed, due to which the increase in indicated power is offset by the increase in loss. Therefore the mechanical efficiency reduces with increase in speed. So the effect of brake. Now I will just draw another graph of speed, same speed versus various parameters. So various parameters I will just draw. So first I will just repeat this indicated power, then this brake power, indicated power, brake power, then this is BS, this is BSFC, this is brake power, specific fuel consumption, and this is mechanical efficiency. So the effect of brake specific fuel consumption with variation of speed is also here represented. So at low speeds with increase in speed, so at low speed, when speed is low, with increase in speed the brakes specific fuel consumption reduces. This is the volumetric and mechanical efficiency is high. So when speed is increasing, the fuel consumption is reducing. Okay, when speed we are increasing. So at certain speed the brake specific fuel consumption increases because of reduction in volumetric efficiency and increased mechanical loss. Then after certain speed the fuel consumption is increased. So here the point x, suppose this is x, so point x represents the economical speed for minimum fuel consumption for the engine. So this will be the economical speed where you have to drive your vehicle for economical consumption of fuel of the engine. So this is the graph, and here also you can see the mechanical efficiency is increasing, and after that speed it is reducing. And I will just draw the third graph. So that is speed versus volumetric efficiency. So here volumetric efficiency will be in such a direction. So the volumetric efficiency with speed, the volumetric efficiency reduces with increasing speed because the drop in pressure at suction caused by increasing velocity of charge to be inducted. So the suction valve will only open when pressure inside the cylinder is slightly below the surrounding pressure, and thus the effective suction stroke is reduced. So it reduces the volume of mixture inducted by lowering the volumetric efficiency. So this was for SI engine. Now we will see second for CI engine. So there is compression ignition engine. I will just draw the graphs again. So similarly with speed and here parameters. So here first I'm drawing is brake power, and this is BSFC. BSFC. So, and let me draw another graph. So there is brake power versus BSFC. BSFC. So here it will be. I will just draw for different engines. That is first is SI engine, and the second is CI engine. So the test is being carried out keeping the speed constant and by varying the throttle from no load to maximum load in case of SI engine, or by varying the fuel supply in case of CI engine. So here we can see that in case of SI engine, so this is SI engine and this is CI engine. So in case of SI engine, the brake specific fuel consumption first decreases with increasing load while working. So as you can see here, decreases. The brake specific consumption decreases with increasing load while working at part loads up to a certain minimum value. Then it starts increasing rapidly. So with further increase of load. So beyond full load, the car starts forming a loop backward point. So here it starts forming a loop to the backward point. Point X, which shows. So suppose this is the point X. So this is the going backward loop, which shows that output decreases, but the fuel consumption increases. So it is due to the fact that the mixture supplied to the engine is too rich and lot goes as unburnt in the exhaust. So such condition of the engine is called choking. So in case of CI engine, so here in case of CI engine, the brake specific fuel consumption versus BP curve is more uniform. So that is more uniform, and specific fuel consumption is lower than the SI engine. So here the consumption, as you can see, it is lower than the SI engine. So it shows the thermal efficiency of CI engine is higher. So the thermal efficiency of CI engine is higher than the SI engine. So here also you can see that this for CI engine, the power versus speed. As speed is increasing, the brake power is increasing, and the specific fuel consumption is also reducing. And after some limit, it is increasing, but not so much in case of CI engine, like in the case of CI engine, like in the case of SI engine. So engine and specific fuel consumption in CI engine is not much affected with variation of in the load of engine. So this shows the performance parameters curve between brake and overall thermal efficiency and mixture strength. So if I want to draw a graph of mixtures, that is lean versus rich mixtures, then and on the y-axis suppose overall efficiency, uh, there is overall thermal efficiency, then I will get, so suppose this is the 50% line, so I'll get just graph in such a manner. So I'll get graph in such a manner. So as you can see that as the mixture leans to rich, so the efficiency is getting reduced because the fuel is getting unburnt. So unburnt fuel is getting in exhaust. So that is the reduction in the overall efficiency. So it shows the slightly weak mixtures as the thermal efficiency is maximum since the fuel supplied will be utilized to the maximum extent. So weak mixtures is having the maximum thermal efficiency because it is utilized to the extent, while the efficiency is low with very lean mixtures. So if the mixture is very low, very lean, then also efficiency will reduce because the mixture of lower maximum temperatures attained after combustion, and also efficiency is low with rich mixtures in the incomplete combustion. So at the both ends the efficiency will be low. So this is the performance characteristics of the CI engine. So in the next lecture we will see various different uh, characteristics and various different uh, performance of the SI and CI engine. So thank you very much.